Alright everybody, so like I mentioned in the last video, in this video we're gonna go ahead and replace this terrible flyback. If you don't remember from the last one, I found the last owner decided to splice the high voltage anode cup and electrical tape it. And again, I mean, I guess it could kind of work, but this is not the proper way to do it, especially when you're talking about extreme high voltage. The flyback itself is also junk in general. It won't adjust in any way, shape, or form. There could be other parts or components, on the board that's causing it, but we're going to be replacing the flyback in this unit, okay? We have a new flyback. It's in the box. I'll show you the new one when it's time to go ahead and replace it. But we're also, in this same video, we're going to test and potentially replace our horizontal output transistor right here, otherwise known as a H.O.T. Okay? I do have a new H.O.T. right there. It's a D1398. I got it in the bag, so you're probably not going to be able to see the number very well. I apologize. But that's a D1398. Now, the reason why we may replace the H.O.T. is because in circuit, and we still have to remove it out of the circuit and test it again, all three legs are shorted to the ground. And that shouldn't be happening, okay? Now, I want to make sure that you understand and know that this could be quote-unquote shorted, not because the actual H.O.T. is bad, but it could have a component in line with it that is shorted and causing a false reading. So the proper way to make sure that it's actually bad is to remove it from the circuit. Typically, if I 100% knew that this was bad, I would just cut the legs and just pull each leg individually and just outright replace it. But I'm not going to do that because I don't know 100% if this is actually bad. It most likely is, but we're going to make sure by pulling it out in the proper way and then retesting it. And I'm going to show you how to do that. Now, another thing that could be is the mica that's right behind it could actually be damaged too, causing the metal ground frame back here, or this metal frame, to short out against the heatsink. And if that happens, well, you're going to have similar readings like I'm having, or you will actually just outright fry your horizontal output transistor. Alright? So, the reason we're doing both of these in the same video versus doing one video on the flyback and one on the H.O.T. is because the way this chassis is designed, in order for me to really get the flyback out without having to fight with it a lot, is I need to remove this heatsink right here that the horizontal output transistor is attached to. So I'm going to make it a twofer inside this same video, okay? The first things we're going to need to do, we need to remove all these screws that are holding everything in place. This screw right here attaches this heatsink to the flyback. So, we got to remove that screw. Just like so. Now, the screw right here attaches this heatsink to the outside frame of the chassis, which is grounded, so that makes this heatsink also grounded. We have to remove that screw, and there's no nut. This doesn't have a nut, and this one doesn't have a nut. So you don't really have to worry about grabbing a hold of a nut on the opposite side with a pair of pliers or your fingers. You just got to remove this screw because this frame right here is threaded. Just be careful when you remove it so you don't strip those threads, otherwise you may have poor connection on your ground. Alright, so that one's removed. Now, the reason why I am sorry about that. But the reason why I talk about the nuts is because the horizontal output transistor does have a nut on the back side of this heatsink. So, when we go ahead and remove this, we want to put a pair of pliers or a finger on the back side to hold the nut in place. Right now, I'm able to do it without a pair of pliers. It's actually generally pretty loose. So I got the nut off. Keep your finger on the back side when you push the screw out, because there may be a washer, a nylon washer or something back there, and there isn't, so we're good. So we'll just take our little screw and our nut, put them together so we don't lose it, and put it back in our little pile. So now the hot is technically free from this chassis piece, or I mean the heatsink. Alright? At this point, what we're going to want to do is flip our board over. And right here, this is where that chassis, or again, I'm sorry, the heatsink is soldered in. So removing this solder here should allow the heatsink to be able to pop off, which will give us all the access we need to safely remove our horizontal output transistor and be able to get our flyback removed as well. Just like any other soldering project, with everything being older solder, we're going to want to add some fresh solder to it, okay? If we don't do that, we may have a bigger problem of a time getting everything removed. Again, this is a huge plane. It's as big, if not bigger, than a ground plane. So it's going to take a bit of heat and a little bit of patience in order to get this to remove, okay? And as you can see, there's also a ground wire attached to this. So, oh, there we go. Got that removed, no problem. Okay. So, it's liquefying quite easily. So our fresh solder took hold. Sorry about that. Hit the camera stand. Had to blow away a piece of extra solder. Now, we're going to be using my solder pult. Now, a solder pult is a suction device that's used to actually suck up the liquid solder. Some people prefer using these devices. Some people prefer using like a H.O.T desoldering gun, where it has its own built-in electric pump. And some people prefer the desoldering braid. I'm a combination of the solder sucker and the braid. I personally would prefer the electronic solder pump, and one day I will have one and we'll get to use one. But for right now, I can only use what I currently have in stock. I don't really like using solder pults, mainly because I'm not so good at using them. I end up burning and melting the tips too much, where I gotta replace them all the time. I'm just very bad with them. But for when it comes to very large solder pieces like this, I'll use the solder pult and the wiki wire, or the desoldering braid, I should say. So what we need to do to use the solder pult with this is get it all heated up again and melted, which again might take a little time. Just be patient and you'll get it to melt. And if you need to, add some more solder just to help yourself out. Okay, so I got this removed, and the way I basically did that was after I added all that fresh solder, I melted this with the iron and just grabbed a hold of the plate and gently wiggled it right out of the socket. That's all I did. Now the plate or the heatsink did heat up, so just be aware of that. If you do the same thing that I did, it's probably going to end up getting quite hot on you, okay? Now, before we move on to the next removal, which is going to be our flyback, we'll do the horizontal output transistor in a little bit. Let's look at our mica that came off the horizontal output transistor, because when I took the heatsink off right here, you can see the thermal paste sitting right there. The mica came off with it as well. So you can see there's thermal paste on the mica. See that? So we're going to clean that off very carefully, because sometimes you get lucky and the mica is actually fine and doesn't have any damage. And if so, it's completely up to you. You could reuse it or put on a new one. If you don't have a new one and the old one's fine, just needs to be cleaned of the old paste, then great. Just be careful when you clean it, because they're super brittle, especially when they're used, and they could crack on you. And looking at it, we actually look pretty good. There's a little bit more of that paste down here. Yeah, I'm not going to be able to get that off. A lot of this is like scratches and stuff, but it's pretty good. We should be able to reuse that. So I'm going to put that in a safe spot so we can reuse the mica. The next step you want to do with the same piece of paper towel is take all this old thermal paste off here, because it's going to be old and cruddy and crumbly in a sense. It's not going to have good connection anymore with transferring the heat that's emitted from the horizontal output transistor into the heatsink. So we want to get rid of all that old stuff so it's fresh and ready for our new thermal paste. Okay, that's pretty much the best I'm going to get it, which is just fine. Cool. Now, like I said, we already got this out, we cleared it out, there's no more solder left. Now we want to work on our flyback, because we have all the room we need now to remove the flyback with no resistance. These legs right here are for the flyback. Now these capacitors on here, that you're gonna find monitors that have capacitors across the different legs on a flyback, like you see right here. The majority of them that are working perfectly fine will not have these. Not unless it's in the manufacturer's design, but in the Gardner K7000, it's not in the manual. So these were added after the fact. So somebody realized there was something going on with the flyback, and they added these capacitors to fix whatever issues they were having. You're going to find certain times when you're going to find boards that have resistors or capacitors or whatnot jumped across certain legs of IC chips or other types of things that were put in place because of an issue that was going on, and they used it as a band-aid. Just like before, let's add some solder to each of the legs so that we have fresh solder, and it should hopefully be easier to melt when it goes to the time of removing the solder. That's for all the legs. Just like so. Now we got that fresh solder on. Let's go ahead and try and remove these capacitors real quick. I could have done this earlier, but yeah, it's okay. This is fine. Alright, there's one cap. Get the next one. Okay. Now from here, we're going to use our solder pult and try and remove as much of the solder as we can. Get it liquefied, get it right in there, and pull it. And we just continue on like that. Okay, so now at this point that I've gone through with the solder sucker or the solder pult, I'm going to go ahead and go through with my desoldering braid and try and clean up the rest of the solder that the solder pult couldn't grab up, essentially. So we'll kind of come in here. We're going to clear this up just enough so we can cleanly pull our flyback out with no problems. It may take a little bit of time, a little bit of patience, because these are larger pads and larger planes and stuff, so there's no guarantee it's going to happen right away or on your first time. Okay, so I went through and I did the best I could with my desoldering braid to clean up all the pads on the flyback. And now we can attempt to remove it. Let's see if we can. Oh, look at that. It popped right out. So that's not too bad, actually. And there it is. Zoom you out a little bit. There's our flyback. Removed. Okay. So, now that the flyback has been removed, I'm just going to look over these solder pads real quick and see if there's any additional solder I need to remove. And it doesn't look like it. Maybe that one right there on that grounding plane. See if maybe that could use a little bit of removal. Okay, good to go. Alright, so that's how we remove our flyback. Now, we're going to go ahead and remove the horizontal output transistor and test it. And the horizontal output transistor is right here. It's this leg, and this one with the red wire on it. And I'm going to just quickly confirm. My apologies. It's this leg, and this leg. So it's these three here. Same procedure as before. We're going to add a little bit of solder to it, and we're also going to try and remove that red wire fast, just so it's out of our way. Now with that pad warmed up, we'll grab with our pliers and, yep, pull that wire off. We'll have to fix the wire a little bit, but nothing too bad. Now from here, we should be able to take our desoldering braid and desolder these legs to remove the transistor, and then we can test it out, and I'll show you how to do that. Okay, so let's see if that was enough to get this bad boy out of here. Now it may be really hot, so be careful. It is pretty hot. See what's not coming loose. This leg right there. So we just got to add a little bit more heat and desoldering braid to remove that little bit of excess that's holding it in place. Okay, that should remove our horizontal output now. Yep, came right out. Okay, so we're going to move this out of the way, and there is our horizontal output transistor. Let me get this better frame for you. So there it is. So now we want to double check to see if this is actually bad. To see if it's worth our time actually replacing it, or we should keep it. So I'll put one probe on the ground plate, and we're going to test the middle. That's good. Okay. Uh-oh, right there. This should not be shorting against that. See the middle leg here, I can't remember which one is the base, the emitter, and the collector, I apologize. But I do know this middle leg right here, this is part of the ground. So hearing this tone is appropriate. We want this. But when it comes to going to this leg and this leg, we should get a resistance reading of some kind. Like with this leg here, we're getting 0.672. This leg as you can hear, it's causing problems. That's shorted. So this is most likely bad. From the sounds of it, it seems to be bad. And one way we can basically double check our findings is take a new one and then test that. So, again, same procedure. Good to go. Resistance. Resistance. No tone. This is a good one. This one is bad. Okay? So we now confirm that our horizontal output transistor for this monitor is bad. So we're going to be replacing it with this new one here. And yes, this is brand new. Well, sort of brand new. It's new old stock. Okay? There you can see the number a little better, I think. There you go. A D1398. So, that's going to get replaced as well. Now let me get all set up, and we're going to start putting in our new flyback, and then of course our new horizontal output transistor. And then that'll be pretty much the end of the video. So be right back, guys. Okay, so I snapped the new flyback in place, as you can see. I would have shown this in the video earlier, but I kind of got a little involved trying to get this to go into place. Whenever you get a new flyback, a lot of the times the legs on it get a little bent out of position, so they don't go in right away. And it takes a bit of finessing and a little bit of fuss to get the legs lined up just right, because you're talking quite a few legs. But I finally got it. It's snapped into place, and now what we need to do is solder it down. So here's our flyback, and we need to get these 2, 4, 6, 8, 10 legs all soldered down into place. Okay? So what I'm going to do is I'm going to get all set up, get my solder paste ready, and we're going to get this soldered back. Okay, so just like videos in the past, we're going to use our solder paste to help the solder go where we want it to go. These being a little bit bigger pads, it's okay and forgivable to add a little bit extra solder paste. Again, you don't really need to, but it's not going to hurt to add just a little bit more for these big pads, especially the ones that are on the ground planes like this one here. So we go around to each one, add our solder paste. Okay, now that our solder paste has been added, we can go ahead and start soldering each of these connections. Just like so. Now with these pads being a little bit larger, you're going to be adding a bit more solder than you would normally, okay? Just remember that. Once you're done, that's what you should have. Some nice little solder joints holding your flyback in place. Now we're going to need to go around with our isopropyl alcohol. Remember, anywhere from 91% to 99% is going to be your best friend when it comes to this. And we need to remove all the excess solder paste from the entire board. Well, at least from where we soldered from, because we're going to add more for any other parts that we work on. And the rubbing alcohol works the best. It really does. And like I mentioned in the past, I like to take a little bit of paper towel and just help it out a bit. Just like so. Just give it some dabs. You don't want to rub it because you're going to cut up your paper towel on the sharp solder points on all the other spots and you'll have issues. Just feel around, make sure it's not sticky, and you're good. And that's that. So, we've just added our flyback. Now, I'm going to get set up and we're going to go ahead and install our heatsink and our horizontal output transistor. So I'll be right back. Alright, so I went ahead and installed the heatsink already. You don't need to see me do that, it's just basic. Just line that one little slot up with the tab on the heatsink, slide it in. I put the screw back into the chassis so that the heatsink is lined up and in the perfect position the way the board needs it to be. Now, with this new flyback is actually much smaller than the original flyback. And that's because this is actually not a new old stock, but a new flyback that was made relatively recently. And with the more newer and advanced technology, things are smaller physically. Just like capacitors. There are going to be capacitors that are much smaller than the capacitors of the same values from back in the 60s, 70s, 80s, and early 90s. It's because technology is making it where the capacitors can become smaller and do the same thing. The same goes with things like flybacks. So, there is no tab for this plate to be screwed into the flyback, which is fine, because you don't need this heatsink for the flyback. It wasn't causing any like ground terminations or anything like that. It was just there as a mounting screw. And this one doesn't require, so we don't need to put that in. So we have this mounted, and what we need to do now is solder that tab back into place. And just like before, we're going to add some solder paste to it, and then we'll solder this back on. And as you can probably remember in the earlier part of the video, we had a grounding wire that was attached to this tab, which we had to reattach, and that's this wire right here. So once we get this soldered in place, we'll reattach that wire as well. So we got our paste on. All we gotta do is just add our heat and then get our solder in there. And this is going to take a lot of solder because this is a very large pad. Alright, just like so. And then from here, we'll go ahead and add our grounding wire back to it. Just like that. Let this solidify. And there we go. Now that's been reattached. So now I'm going to go ahead and set up and put in the horizontal output transistor, and we'll be pretty much done. So I'll be right back. Alright, so now we have the flyback in place. So let's go ahead and get this horizontal output transistor put in place. Off camera, I already went and bent the legs. It's pretty basic. Just bend whatever legs need to be bent so they can make it through the through holes. And in this case, only the middle leg here needed to actually be bent. And I did my best to copy the original. And I won't lie, I tested it out off camera and it goes right through in the slots, no problem. So, I did pretty good. But, the thing is, these types of transistors have metal backs, like you can see here. And if I were to just put it in as it is, I'm going to short this thing out and it's going to fry on me. And I don't want that. So what we need to do is we're going to take some of this silicone heat transfer compound. Basically thermal paste. It's just like a different version of thermal paste. It's a white kind of like paste that you're going to put on. And we're going to put it on the back of the transistor. And then we'll put our mica on the back of the transistor. And we'll also put a little bit of thermal paste on the back of the mica, so that it will transfer all the heat through this transistor into this heatsink here, keeping the transistor working at its optimal range for as long as possible. Now, the easiest way to do this is just take a little bit of paste out, put it on your finger, and then put it on the transistor's back. I just like to put a gob on, just like so. Because when you put on the mica, it's basically going to squeeze it out and press it across the entire transistor very evenly. So we'll take the mica and we're just going to push it down. See how that kind of like spread out? It'll spread out even more after we get the screw put in and we tighten it down. Now before we do that, we're going to want to put a little more of this paste on the back side of that mica, so that when we screw it down, we get a little bit of thermal paste right on the heatsink itself, which is going to help it transfer the heat from the transistor a little more effectively. Now you can put it on the mica or you can put it right on the heatsink itself. It really doesn't matter, as long as you're getting a nice connection of thermal paste to transfer all that heat out. Okay, so the next step from here is we're going to go ahead and get our screw, and we're going to put that right through and try and get that all lined up with our mica that has a hole already in it, just like this. Okay, then we'll get this put into place. Now it takes a little bit of finessing. I apologize if I'm blocking the view. I'm going to do my best not to block the view, but I can't promise it's going to be perfect. Slide into the hole, which it did it earlier for me, but now it doesn't want to. Go figure, right? As soon as I turn the camera on, it's going to be a pain in the butt for me. It's always that way. There we go. Then we just get the screw through any of the holes that are on there. Then we get the nut on the back side. Take our screwdriver and tighten this down. Remember, we do all of this here before we solder it in place. So then we know that the transistor is in a proper position. Okay, so we'll tighten it down. Alright, and as you can see, as I was doing that, you saw that all that thermal paste just basically spread throughout the entire transistor and the heatsink, which is perfect. That's what we want. We want to have a nice, even layer of that going all the way around, so we really know that the heat is being transferred into the heatsink. Now from here, we'll just flip it over. Okay. Okay. So what we're going to be doing is adding some solder paste and the solder to this leg, and this leg right here. Once we get that done, we'll add that red wire you saw earlier in the video back to the center or the ground tab right here. But before we do that, let's just get this thing soldered into place, and then we can worry about that little extra bit of wire afterward. So we're going to add our solder paste like we've done before. Just like so. Okay. That's been taken care of. Let's go ahead and get our solder iron and our solder. And we're going to go ahead and get this all connected back together. One. And there's our third leg. Excellent. Alright. Now that that's been soldered into place, our next step is to use our rubbing alcohol and clean off any of the excess solder paste. We don't need to keep the solder paste on here to put that wire on our ground leg, because it'll attach with no problems whatsoever at this point. Okay, got that scrubbed up. Now we'll just give it some dabs here. Like I mentioned before, you can just let it air dry because it is rubbing alcohol. It will do that, but I'm impatient. Okay, now that that's done, we'll run our red wire, which is this wire right here, through the hole that goes right in front of the transistor. Like so. Okay. And then we're gonna solder this wire directly to this leg of the transistor. Before I do that, I'm just gonna bend the wire a little bit, the soldered part of the wire, the tinned part, so that it lays a little flatter as I do this. So I'll grab a hold of the insulation carefully. Attempt to, that is. Get some more of this wire pulled out. It makes it easier and you have more to work with. Now you don't want to put a lot of pressure on here. I mean, if you flatten the insulation on this wire a little bit, it's not a huge deal. But if you can try to avoid it a little bit, it's better that way. Okay, that should work out just fine like that. Okay. Alright, so our wire is in place now. So at this point, we'll go ahead and just trim the excess of our legs on the transistor off. Just like that. And we got our horizontal output transistor replaced. Now I'm going to get you all set up, and we're going to finish the last little bits with the flyback, and we'll be done with this video. Okay, so now it's time to work on our flyback here. The first thing we need to do is connect this main red wire, okay? This is part of our cathode wire. It's a high voltage positive wire. And it's going to go into the neck board right there where you see that hole, okay? Typically, there is a pin on here that a connector will slide onto. But, unfortunately, this flyback did not come with a connector already put onto the wire, and I don't have the types of connectors I need in order to hook it to the pin. So I removed this pin ahead of time, and what we're going to do is we're just going to solder this wire into place. And I will tell you, normally I wouldn't do this if I'm working on a customer's board or somebody else's TV. I would order the parts needed for it. But since this is for my own personal arcade machine, I don't care, and I'm just going to solder it in, because it's going to be the same thing. The only difference is, in the future, if I ever need to remove anything, I have to desolder this wire versus just pulling it off the plug. So what we're going to do is we're going to put the wire through this hole here, just like that, come to the opposite side, and just like anything else, we're going to add a little bit of solder paste to it, okay? So I'll see if I can't zoom you in a little bit better. It's probably the best I'm going to really get with this crappy camera. So, we'll go ahead and we'll add our little bit of solder paste. Just like so. And by the way, this wire does come pre-tinned. So you don't have to worry about tinning the wire. Okay. So, we got the solder paste on. And all we got to do is solder that wire into place. Just like so. Okay. And exactly just like before, we use solder paste. So we're going to take our rubbing alcohol and we're going to clean this up a little bit. And because I'm impatient, we're going to take our paper towel and we're going to dab it. Just so it's nice and dry. And there we go. Right there. You know, the camera's not really picking it up very well. But it's soldered in, and we're good to go. Now the final step is we need to take our grounding wire, alright? And we need to reconnect it to the socket right here. And if you forgot from earlier in the video, we gotta take a flat blade screwdriver and pop this tab up. Just like so. Because remember, it's a locking tab that locks it down. So we'll take our wire. And we're going to put this right into that hole here. Just like so. All the way down. And while you push it down, take this tab and snap it into place. And that, right there, will lock this wire. See? It's not coming out. So we have a good connection. That's our ground connection to the socket. And there you have it. That's how you replace a flyback transformer and a horizontal output transistor on a Wells Gardner K7000. And of course, just like you saw in the previous video, we've already replaced the socket on the neck board, and now you know how to reconnect the wire, the grounding wire that goes to the socket. So on the next video, we're going to discuss how to do a capacitor kit on a Wells Gardner K7000. We're also going to replace these very basic 3904 transistors. There's like 4 or 6 of them, something like that. These may be fine, but because of how old they are, these are original. I'm going to replace them with brand new ones just to give it a little bit better chance. And after all that is said and done, we're going to hook it back up to the monitor and we're going to see if it works. So thanks for watching, guys, and we'll see you on the next one.